difficult to find time. Sorry for that. If you were waiting for me for recent days, I'm very sorry. I cannot give to these streams appropriate priority. I'm sorry for that. But anyway, I'm back, and I want to continue. I want to finish with you this important project. And we are in the Lean Six Sigma DMAIC Green Belt Project Book creation streams. Okay, let's check if we are on Facebook. Yes, we are. So I hope you are fine. I hope you are healthy. I hope you are far away from the virus, and we continue. So I think it would be good to have a small recap from what we did last time. So actually we are for a few sessions already in the Analyse phase, and the Analyse phase is to first we have to, the whole Analyse phase is to collect the evidences and proofs based on dates and figures and statistical analysis for what really is causing the problem we are facing. And the whole the Analyse phase, from my perspective, is one of the most important. Of course, every step in the DMAIC phase is important, but the Analyse phase is what is making the Lean Six Sigma powerful. And also the Analyse phase is making Lean Six Sigma different from other root cause problem solving techniques, because we are combining here two very important elements. One is we use a brainstorm techniques to highlight and to choose the most probable root causes for the problem, and then we apply on this selected root causes a statistical analysis to be sure, 100% sure, that this has a statistical impact to the problem, because otherwise it may not be worth looking for some solutions to eliminate this potential root cause. And what I think we managed so far. Hello, how are you? So I think what we managed to achieve so far, let me have a look, okay, is that we discussed about how to conduct the brainstorm session. Then we also discussed about the there was a brainstorm session and Ishikawa, because we are using Ishikawa to make sure that so here is the question, why we are so far from CTQ, and we are looking for potential root causes at each of Ishikawa area. So it's man, machine, material, method, measurements, and mother nature. We are using Ishikawa to be more precise, more complete in identifying the potential root causes. If we miss one of the Ishikawa areas, there is a risk that we may just skip very important root cause. So we are using this. We discussed already that we have to use a working area to collect all the ideas and the answers to the question, put it on the post-it, we put on the wall, we analyze each of the Ishikawa areas, and we are applying certain kind of sieves to eliminate. So first in the brainstorm, our main goal is to create as much as possible. So in our first step of the brainstorm is the quantity. This is our goal. Once we have the huge amount of potential root causes, we are narrowing down them to find a more practical and more probable root causes. The most probable root causes, not potential, but the most probable root causes. And one of the sieves, yesterday we also, last time we discussed also about the The quantities you want to, the sample size, sampling in general. You remember that the sampling, there is always a risk in sampling that we will not have the full picture. So I simply encourage you, if you have the full population, just take the full population for the analyze. But these two elements, you know what I will do? I will just move them back to the measure phase, because these elements are more to the measure phase than to analyze phase. Okay, let's do like this. So we have here a measure, do a trace data, yes, the sample size, and then we talk about the error. Okay, great. So here we have the Ishikawa, and one important element regarding the Ishikawa. Normally the Ishikawa we are using a post factum. So once we spot the problem and we start to solve the problem, I mean the problem is already there. We cannot go back in time and change something that the problem will not appear currently. So the problem is done already. We can only think for the future what we can do differently, not to face the same problem again. This is actually the problem solving. So we solve the problem, we are looking for some solutions, not to make the same problem again. But the problem is done, we cannot change this. Therefore, I encourage you to use Ishikawa before changes. When you prepare for changes, when you talk with your team on the project, why not to use Ishikawa at that moment before facing problems, when we forget about something from Ishikawa, because this is normally like that. So we are facing some problems because someone forgot, for example, think about the people in the process and didn't recognize that we are missing one person, and then we are not able to achieve the target. Or perhaps someone forgot about machine subject and didn't prepare the machine for the new speed or new tolerance. I mean, it doesn't matter. The problems are very often because we simply forget about the Ishikawa. So I suggest you to think and not forget about Ishikawa at every stage of your project. Or if you are implementing a new product, new process, you do something new, you're implementing new machines, new technology, you change something in your team, you have new customer, new product, new area, new market, always take Ishikawa in advance and ask the questions before spending some money, before investing. Okay, so this is why I put here this graph, and I encourage you to think about and ask the questions before, are we prepared for changes? Okay, so the first sieve we will use for our huge quantity of potential root causes is nothing else but a practical approach to what can be changed. And because I don't want you to struggle with some potential root causes that you will finally and you will never be able to change. We want to be as quick as possible, as effective as possible. So let's also choose reasonable and realistic root causes where we can really implement changes. This is why we have to look at our potential root causes from the brainstorm session and divide them into 3 categories. Sorry, we have to divide them into 3 groups. One, when we talk about is it really possible that certain root cause may cause the problem? And what we are looking at, we are trying to understand and analyze if we were spotting changes and difference and variation in the output in our Y. So the problem is always that we are comparing the variation based we are comparing variation with the expectation from the customer, and sometimes it's going up and down, and there is a lot of situations when it's not fitting the tolerance, and this is the problem. So when we are observing this variation and suddenly certain root cause is always stable in this period of time when we are conducting the analyze, there is no possibility that this stable root cause may cause this variation. So you cannot explain why sometimes it's good, sometimes it's bad, when you have always the same level of your potential root cause. It's always there, or it's never there. It's always the same. So whatever it looks as stable in the time when you're observing the up and down, up and down, up and down, you simply can cross it out. Do not take it into the analyze, because anyway you will learn from the statistical analyze that it has no impact. Okay. Also into this group we put root causes that we definitely have no impact at all. Like it's too heavy, too difficult, too costly. We cannot influence the government. We cannot influence the worldwide economy. We cannot influence the worldwide climate changes, and so on, so on. So if someone is saying like, okay, we are facing this because the climate is changing. Okay, so what we can do? By the way, the climate is changing. It means it's not stable, so it will not be C. Yes, but anyway, so we're trying to find and look for the potential root causes that have no chances to be a winner at the end of the analyze phase. Okay, so we cross it out. We put a red dot on that. You see, there was an example. No, here we have already a vote. Okay, I will come soon to this. So we have a voting here. So no, we will. This is already after this first sieve. Okay, anyway, so how we can do this? We of course we have to come in the front of the Ishikawa board where we have all the potential root causes, and we just discuss with the team. Is it C or not? Is it red or not? Should we mark here C or red dot or not? Okay, and the best is always to discuss this with the team. The voice of the team is always more accurate, more correct than your personal opinion about certain situation. Remember that. Okay, so there is a first category C. Also, why we are not taking this further, because any time, any cost spent to influence this kind of root causes simply will be a loss of time, loss of money. You will gain nothing. There will be no change. Okay, and then we have the rest actually is changing. Yes, so it was a stable or far above beyond our power of influence. Yes, so we have only, and then we have a rest is definitely changing, and then we are dividing the rest into two groups. Okay, we know all of them are changing. Yes. So this may have an impact, and we just make a small decision. Are we able to change this or not? Do we have enough money, resources, and power to change or not? If we are not able to change, it may stay as the natural noise in the process. So the noise is the potential root causes that are always changing. It may have impact or not, and it's too difficult to impact them, too difficult to control them. An example may be like a vibration of the molecule in the air, or in how we cannot influence the micro world, yes, because it's too costly. Or perhaps you have the gas has a temperature inside the tank, and you would like to control this, and you cannot measure it. So there is a lot of vibrations around us that we don't care. We do not care. Yes, we don't care because of different reasons. It's too costly, too difficult, and they are causing our effects vibrating, moving from the nominal value up and down, up and down, up and down. So this is like a noise. This is causing a normal vibration, normal deviation. This is why we are calling a process which is under the influence of only this kind of potential root causes. This is why we are calling this normal distributed. Yes, the probability is normally distributed because the small root causes are so common and normal for the process that we see a normal distribution. Okay, and then we have the Then we have the last category, our the X means that it's changing, and we definitely in the position, we have a power, we have the money, we have resources to change this. And this is why we are making a boundary between the X and the N, so the variables and the noise. And very often this boundary is shifting once we are getting more resources. So I was giving an example last week when, for example, we invite to our brainstorm session an owner of the company, or head, or general manager. And once he is in the meeting, the boundary between the variables and the noise is going up. So more we can consider as variables and less we can consider as noises, because with this team member in our team we have more power. Less people with big impact, we have limited possibilities. And this is why very often, for example, when we would like to start a very small, a very quick, a Kaizen workshop, Kaizen workout with a small group of people from the production, and we don't want them to go into very difficult subjects where the investment has to be calculated. We just want them to be engaged in a very simple solutions just on the shop floor around them. We even eliminate the Ishikawa elements, not focus them to measurements or Mother Nature because it's always costly. So just look at the way how we cooperate and communicate. So there's always a man, method, machine, material. So we are narrowing down, yes, and we are by definition we are telling them, okay, do not look at this point, do not go in that direction because it's definitely beyond your responsibilities, and we don't want you to waste time. So focus on what is possible. Focus on what we can implement. Yes, impact. And this is the main idea of the first sieve. So see, so we are going from this a big group of potential root causes. You remember when we were creating this huge number of potential root causes, our main goal was to eliminate all boundaries that is stopping us from achieving the high quantity. Yes? Hello, how are you? Okay. Oh, hello, Syed Ali. I hope you're fine. Are you interested in Lean Six Sigma? Do you have already Green Belt certificate? Or you are just thinking about this? Okay, I hope you are really healthy, you are safe, your family is safe from the virus. And if you have some time, just focus, follow, listen. If you have some questions regarding the Lean Six Sigma, please ask the questions. I am always here to answer the questions. Okay. By the way, I really think that the Lean Six Sigma approach, so everything what we are talking about here, will definitely help any companies in recovering from the crisis after the pandemic will stop. Everyone will have to really catch up what was lost in the economy, and only through effective and errorless processes we can achieve this. Okay, and this is not only why I'm talking about. Of course, I believe that this way of thinking may change the way who you are, and it will just make you a better person. Okay, anyway, so we are splitting, divided. So from this huge amount of potential root causes, we are going down, and the end will be the more practical root causes. Okay, and this is how we will reflect this in our root cause. How we will show this in our spreadsheet. Okay, moment. Good. I think we are ready right now. So look, if you will take our Google spreadsheet for the Lean Six Sigma DMAIC project, you may see in the Analyse phase there is already a prepared okay, there's already prepared. Okay, good. So prepared table where you just take the post-its from the wall, you write it down, and you indicate here what are the potential root causes. Now, there are potential root causes here from the men. So let's follow the same sequence. I mean the same methodology. Let's do like this. So this will be this one. Great. This will be machine. Here will be the material. Here will be the measurement. Here will be the method, and the last is Mother Nature. Great. I will do a bit longer. Great. So we are put here 1, 2, 3, 4. I mean, you can put more, of course. It's up to you. Then you just indicate this is the constant, noise, or variable. And what I suggest, list of all variables. So here we should have here the only x. So I will copy it here because it will show exactly yes. So there is a number. So what I encourage, I don't know how to make it automatically, but I will not do this because okay. So now I will just make an example. You just make a copy of this. So root cause number 1, root cause number 2. Okay. But before that, no. I just want to show you something different. I don't know why I simply forget about this. Good. So we have here, oh no. It's not so easy. Okay, good. So here we should have, oh, okay, let's do like this. I will follow, delete columns. Great. So we have the variables, and then it will, I can guarantee you that even if you do a measure phase properly, if you present to your team before the brainstorm all the evidences you managed to collect about the problem, if you go with your team to Gemba and see the process with your own eyes, and when you discuss about what you have just observed, then I guarantee you that you will have a lot of potential root causes. Okay, and then even after the first sieve, when you cross out, hello, let's have a look. I'm just looking at the YouTube, and we have one person on YouTube. I hope you are not asking the questions and I'm not answering. It would be a shame. Hello, English. My English is bad. Be for fun. Don't worry. My English is also bad. My English is bad, and you have to always start with English. Don't worry. It will come. It will come. So, coming back to the spreadsheet. So, so I guarantee you, once you will really do your homework for the define measure phase and do the proper brainstorming, you will have a lot of potential variables. So already after the first sieve, and what you will do with each of the variable, you will soon, during the next step in the analyze phase, you will try to understand them, describe in numbers, and apply some statistical techniques to collecting evidences. So you will soon come to a very precise actions toward each variable you will choose, and this will require, quite a big focus and understanding what the potential variable is, what was the meaning of this. And you will notice that very often the first answers when you collect the Ishikawa, when you have the post-its, you will find that the people, your team members, they will put on the paper any kind of thoughts. They will put a general or very precise, a very foggy, or just one word, for example, because they will simply put the emotions on the paper. Yeah, and it's good. You should not stop them. You should not criticize for that. You should allow them to do whatever they want. More post-its is better. But then, it will even appear when you will do the constant noise and variable sieve, because to really identify and precisely indicate, is it a constant noise or variable? Let's insert 5 left. Great. You have to really understand what is this all about, and this is the moment when we have to apply a very specific tool and techniques. Okay. Let me show the presentation for that. Good. So, what I'm talking about. I'm wondering, have you ever had to sell something? Did you ever had a chance to work as the salesman? A salesman is going from door to door, knocking the door and saying, "Dear man or man, dear lady, mom, man, would like to buy this," and you are showing like a cell phone. Okay, would like to buy this? I would like to offer it to you. This is a great product. Yes. So if you ever had this opportunity to work as the salesman, honestly, personally, I think the selling something is the most difficult job you can ever have, because as the salesman, statistically, you facing much more often. You are facing certain situation which is very frustrating, very difficult to come over and to understand even. Yes. So what I'm talking about when your customer is saying no, I don't want to buy. So this is why the salesman is hearing a no the most often times from any kind of other job. No one is listening no so often like a salesman, and this is very frustrating. This is a very hard job, and if someone is really successful salesman, I respect this, because this is a very hard and difficult job. So and when you are a young salesman, when you are only like entering this profession and you have no chance to train yourself or listen from the better or older colleagues how to sell something, you may just say, "Okay, sorry, I didn't want to disturb, so bye, thank you very much," and you're going to the next door. But there is also a very simple techniques. When your customer is saying no, you should always try to use the situation to learn something about what is the root cause, why the customer don't want to buy this. The situation is very difficult because every salesman is taking this personally. If you hear no, it means the potential customer don't like you. This is the personal opinion about you, which is of course wrong, because the customer may say no due to many other reasons. Yes, it's never like he don't like you. If you look ugly, if you are not dressed properly, if you are not polite, then no may be maybe of course pointed at you, but in most of the cases it's not about you, it's about situation, a product, or whatever. So the good salesman is taking the opportunity to learn something. Okay, he's listening. No, he's not taking this personally. He's not starting to question, to defend the product or push customer. Well, okay, I understand. His answer is very simple. I understand. Thank you very much. Can you tell me, dear customer, why don't? Can you tell me what is the reason why you don't want to buy this product? So he is at least trying to learn something. Yes, and of course you have to understand what the customer is thinking at that moment. He definitely. I mean, there is never a good moment when the salesman is knocking your doors. You always have something else to do. You always plan to do something else, and someone is knocking, is calling you, and trying to sell something. There is never a right time to talk to the salesman. So the customer, in most of the cases, he wants to just stop a discussion, get rid of this person. He wants to come back to his activities that he was doing, and he was interrupted. Yes, so he wants to come back to the situation and to the activities he was performing, doing before. So he will give to the salesman first answer that he think he may take it as granted and go away. It may never be a true answer, but it will, from the customer point of view, it can give the most of the chances to give away, to get rid of the salesman, yes, from the doorsteps. So this is why the first answer to the first question, why, which is not always the true, and what the old and experienced salesman is doing. He's saying, okay, I understand. He's writing down the answer. He's showing that he's listening. I understand. Yes, he's writing down the answer, and he's starting to guess. Is there other reason why you don't want to buy this, perhaps? And if we are continuing to asking the why, soon we find and hear the right answer. The answer that will be more close to the truth. And this is why the best techniques in learning the truth is asking the questions why 5 times. You remember this 5 times why? Actually, you don't need to ask 5 times why, but at least you have to ask few times why. Definitely not the first one. If you decided to ask the first question why, you should at least continue with the second question. You should never stop with the first question. Okay? So the first question why, and then the second. It may also be a case that the root cause on the post-it is so clear that no one has any doubts. Everything is clear, and you don't need to go through 5 times why through all the potential root causes, all the post-its. Choose only these post-its when you have some doubts, when you have to discuss, is it really constant, or it's noise, or it's variable? Do we have any impact on that or not? So only if you have some doubts, only if you don't know how to proceed further with that, okay? Okay, good. So what we'll do now, let me have a look here. Okay, we are in the PowerPoint presentation. So the second sieve definitely is 5 times why. Let's do like let's take this one, and we just ask here why, and the reason and the goal of why First, of course, you have to understand we should not argue. We are not arguing with the person to whom we are asking why. We are just listening, writing down, and we are asking the same question again. So again and again and again. So why? So going down and again and again. Okay, good. So it's more like narrowing down the area of the problem, and by asking different questions. Why? Moment. Thank you very much. Okay. And I'm doing this on purpose. I'm not writing here 5 times why, because it's not always a rule that you have to ask several 5 questions, 5 times questions. So 5 times why. Okay. So the idea here is to really understand the real root cause, not just to take as granted what was written, what you heard from as the first time. You should always try to understand what is beneath, what is under the problem, what is the real root cause. You are going to the real root causes by asking several times why. And I want you to write it down, the results of several whys here in the spreadsheet by, you know, answer 1, 2, and so on, okay. And then if you have several questions, or perhaps I don't know, I will change this. I will do like this, because actually you should ask. Okay, good. This is more realistic. So first you are asking why, and then finally you are defining, is it constant or not? Okay. Okay. Are you familiar with that? Are you familiar with that? Did you ever use this kind of techniques before in your brainstorming sessions? This is interesting for me. If you have, of course, your own approach, you can use your own method of identifying the root causes. In these cases, you're taking your own risk. You are using this for your own risk. Your main goal is to find at the end the most probable root causes, and this is the most important. I'm just giving you some suggestions how you can what you can choose. Okay. So coming back to our spreadsheet, we are putting here the answers. You don't need to stick to following 5S for each potential root cause, but wherever you feel the statement is too general, you have to narrow it down. And then we are going to the last sieve. The last sieve is when you still have only variables. So I will do like this. I will call it second sieve, but I will represent it before the C and X. So then you work only with X. Okay. And you definitely will have a lot of potential root causes. So I will do like this. Like this. Okay. Then we sort it out. First we will rozłóż w pionie. And we... This is interesting. Sorry. I didn't want this. Okay. What? I was just lucky. Great. So we have a list of potential root causes. and still the number of root causes may be big enough to engage you with the analyze through all the year. So still definitely is too much. You have to narrow it down, and the only one is to do a voting. Yes, a simple voting. And the voting when let's me like this. Here we have the n is the number of potential root causes, okay, the potential variables, and the voting is based on certain rule that a number of votes is equal n divided by 3. Okay, so for example, if you have the 12 potential root causes, 12 variables, you divide it by 3, you have 4 votes per team member. Per team member. Okay, so every team member gets the 4 votes, and these votes can be placed. No, sorry, not this one. These votes can be shared as you want. You can put 2 per 1 variables, 3 per 1 variables. It's up to you. But each member is voting separately. Sorry. Each member is voting separately. Separately. I'm not sure if this is correct in English. Sorry for that. I have to very quick. No. I have to very quick check this. Okay, each member is voting separately. Okay, and then when you have the number of votes, what you do? You just do a Pareto. I think there was a Pareto before. I think I talked to you about Pareto. If not, I have to spend some. Okay, so this will be like good introduction to the next to tomorrow's session. So after voting, we have to do a Pareto. Pareto is the great tool to show you what has the biggest impact. And among all the possible variables, the biggest impact has definitely this one with the highest number of votes. And the Pareto analysis will show us very clearly which variable got the most number of votes, and this is why it has the biggest impacts. So Pareto. Great. So tomorrow will be about Pareto. That's nice topic. What do you think? But let me have a look at the spreadsheet. I think what about the define phase? There is no Pareto in the define phase. In the measure phase, there is no Pareto as well. Good. So this is a great opportunity to talk about Pareto. So thank you very much for being with me today. You see, we went through the next step. We are very close to what is the most. Be for fun. Wytłumaczę Ci wszystko, słuchaj, w swoim czasie. Możesz też zobaczyć moje inne streamy po polsku. Są na moim kanale. So, thank you very much for being with me. So, tomorrow we talk about Pareto, and you will see how we can identify the variables with the most number of votes, and then we select a small group for our statistical analysis. Thank you very much for being with me, and see you tomorrow. And if you have any doubts, if you think this material is interesting for you, for your suppliers, for your customers, please share it with them. and spread it around you. And if you have any questions regarding Lean Six Sigma, please also leave the message and comments on Facebook or YouTube. Thank you very much.